Hello everyone, my name is Radu Emanuel Kishkariu. I'm a security research engineer at XE Application Threat Intelligence team. And today I'm going to talk about a web application vulnerability that was extensively exploited in the wild. The vulnerability appeared this year. It's a remote code execution vulnerability that affected virtually all versions of Drupal content management system. Because of that, it received the name Drupalgeddon 2. You might wonder why is it called Drupalgeddon 2 instead of Drupalgeddon 1. That is because the initial vulnerability was published in 2014, and it's a SQL injection vulnerability. So the vulnerability was identified by the Drupal security team, and it made a lot of noise on the media too. As a follow-up, 2 weeks after the initial vulnerability was identified and patched, another vulnerability, this time an authenticated remote code execution vulnerability has appeared. This also made a lot of noise in the wild, and it made the headlines of a lot of articles. So you might wonder what happened. Let's take a look at the attack timeline. On 21st of March, the Drupalgeddon 2 vulnerability was patched by the Drupal team. Then, a week later, they made an official announcement that instructed everyone about the vulnerability and how to patch it. This is a form of responsible disclosure in which the vulnerability is patched first, and after that, you will get information on how to patch it and what are and general information about it. Then a few days later, a proof of concept for this vulnerability was made public, and the attackers started to use it widely. A different thing entirely happened with the Drupalgeddon 3 vulnerability. This time, the attackers were faster. They published a proof of concept for this vulnerability and made it public before the Drupal security team had the chance to publish the security patch and the official the security advisory for it. Okay, so in order to understand what's going on with this vulnerability, we'll have to take a look at the core functionality of Drupal first. We have this form API, which the developer can use to create and present forms to the end user. And its basic building blocks are the so-called renderable arrays. What are renderable arrays? Well, they are simply PHP arrays that are very similar with the Python dictionaries. They map keys to HTML tags, and the keys can be either properties or form elements. So what happens when a user makes a request? Well, the parameters of the user request are transformed in a PHP array this is going to be used to retrieve the actual form. And the information about the form are going to be sent to the rendering module. Of course, the information about the form are going to be represented in a renderable array, and they're going to contain either properties or form elements, and that is going to affect the outcome of the rendering process. Okay, so where exactly the vulnerability lies? The vulnerability is within the rendering module. So we have the doRender function, which takes as argument the elements array that we talked about earlier. If a property such as post-render is present within the elements array, then a call user function will be executed, having as parameters a callable argument and some components of the elements array which have the children property set. In other words, the callable function will be executed having as argument the components of the elements array with the children property set. But what that means is that this execution is made without any form of sanitization whatsoever. More exactly, the callable function can be any PHP function that we want, for example, exec or pass-through, and alongside we can specify a Linux command, and maybe that is going to be executed on the remote server. But the only thing that we need is an entry point, in a way to somehow specify the property alongside the other components. So what can we do? It turns out that we have such an entry point, which is represented by managed file.php. This is simply a form for upload and save files on the Drupal instance, and it works by creating an AJAX response that invokes the upload AJAX callback function. This will take as arguments in principle our request. Then it will turn it. It will turn it on a PHP array, which is used to actually retrieve the form that we want to render. After that, we are using that nested renderable array, and we're going to send it directly to the rendering function that we saw it earlier. So this is exactly what we need to specify the arguments in order to exploit this. Okay, with this in mind, how the actual exploit looks like. Well, it's pretty simple. You just have to specify the post-render property. Then we will specify PHP functions, in this case exec, alongside with the Linux command that we want to execute. And lo and behold, the vulnerable server will respond us with the output of the Linux command. Pretty neat, right? Okay, now that we saw where the vulnerability lies and how can it be exploited, let's see how the Drupal team responded to it. Well, they thought about it and they decided that they're going to build a sanitizer module, which is going to be introduced at Drupal Bootstrap, which happens exactly after the site loads its configuration. So what is in this sanitizer module? It contains a method called strip dangerous values. As its name implies, it will simply parse our request for the hash character, which would imply that we're trying to set the pre-render or post-render property. What do you think? This is a good idea? Well, I personally think that this is not a good idea because you can simply URI encode the hash character and pass the same request, and you will probably manage to bypass this patch. Other thing that might happen is that there may be certain forms that are not going to pass this routine. For example, some cached forms or some forms that require user interaction as a confirm form, and it will bypass the patch altogether. And this is exactly what happened with the Drupal 3 vulnerability. Okay. Now that we know how they patched it, or how they wrongfully patched it, let's take a look at the malicious activity. Our network of honeypots started to intercept Drupalgeddon to related activity 2 days after a proof of concept for Drupalgeddon to vulnerability has appeared. We obtained approximately 8,000 hits on our honeypots, culminating with 1,600 events during 7th of May, which is 2 days after both POC had made public. We can also infer the distribution of the source of the attacks, that of the total number of attacks. This is pretty interesting because we would expect that most of the source of the attacks should be countries like China, so on. But of course, the attackers are smart. They are going to use proxy services or VPN services, and it's interesting to see what are their preferences. Other thing that might affect this distribution is the fact that maybe some attackers won't conduct their malicious activities from using a certain VPN or proxy because they don't trust that. They will try to actually infect certain machines from countries such as this, which are predominantly English-speaking countries, and they will conduct their attack from there. Okay. Now to the interesting part. We saw their general behavior. Now let's take a look at some actual samples. The first one is an easy enough sample. It's a PHP agent. We see that this attacker is going to use the Drupal to exploit in order to deliver a PHP file. So let's see what's within that. Okay. This looks pretty obfuscated, but it's not so bad. Usually when faced with samples such as these, we can replace the variables, arrange the code a little bit, and maybe base 64 decode the ugly string, and More importantly, switch the eval to echo or something in order to be sure that we won't execute malicious code on our machine. This is the output after we managed to deobfuscate it. We see that is simply enough PHP file uploader that the attacker can use to further compromise the machine. This is usually used in what is called a staging attack. The attacker doesn't want to make a lot of noise. They don't want to trigger. They use the exploit to simply run a command. You would use a file with a name that won't trigger, won't make you question what that is, and we'll simply use that to upload its needed files. Okay. Now the second sample. This is a little bit more interesting. This attacker is going to use the exploit for Drupalgeddon to vulnerability in order to download a resource from a domain that on his control. After that, he is trying to execute what seems to be a shell script. So let's see what's within that. This is getting interesting. Looking at this, we're kind of understanding what the attacker is up to. So he's thinking, I want to use the Drupal to exploit in order to make some money, push some coins onto my wallet. But maybe other attacker is quicker than me and he's going to compromise the machine ahead of me. So what can I do? I will simply inspect all the processes that are running on the vulnerable machine, and I'm trying to kill all of that, so no honor amongst thieves. Probably what is going to follow, and he's trying to start his mining process. But let's see. This time, the attacker needs some dependencies, and he is assuring that this is happening by installing them. After that, he is trying to achieve persistency. So if the vulnerable machine is going to be restarted, we simply insert some cron jobs and continue to make money for his wallet. Okay, let's continue. Now this is more interesting. He is going to use an SSH backdoor key, and we'll introduce it on the authorized keys to assure that he has access to the compromised machine. Then, more importantly, he is downloading on the vulnerable machine more resources, and we see that are two files of interest that are copied to TMP, client migrations. One of them we already suspect that is going to be the miner. But what is happening with the next one? As we expected, the files are executed, TMP client, TMP migrations. From this, we can infer that the migration is actually coin miner, but we still have to see what is with the other file. Of course, he is expecting if the process is starting, and if it's not, it's probably a missing library, so he solves that by downloading it and running with the client miner. Okay, so we know this. We know that TMP migration is probably the client miner. He is using a miner pool and specifies it, and the other file gets executed directly. So we have to see what's within it. Just to make sure, let's look again at file migrations. This is UP-expect, so we're trying to unpack it. This time is in a binary executable file. Inspecting the strings, we see that indeed it's a Monero coin miner, and you see we can specify the mining pool, and this is how he achieves it. But we're left with the question, what's within the other file? This is directly on binary executable, but it's cool that it's statically linked, and it's also not stripped, so we can inspect it further. So I got curious, and I started to look within it. Now, this is interesting, because we can see strings such as attack base, TCP attack, or loop CMD, shell command, which would probably suggest that we're facing with a client for a botnet. Also, there are a bunch of IPs present in the binary file. Looking for them, we can see that or have been reported as being pertaining to domains that were conducting malicious activities. But I wanted to look further into it, so I used GDB and Hopper disassembly in order to understand what's going on there. For starters, it has some anti-debugging logic going on, so if you're trying to execute it within GDB, it will cease the execution. Also, there is an important method which I entitled start backdoor. And I started to look within that. This method will call a method which I entitled deploy backdoor. And here there are three things of interest. There is main baycong, its main monitor, and main backdoor. What happens here? A bunch of information about the machine are obtained, information such as the CPU load, network load, and so on. And they are sent within the main monitor method to the command and control server. We see some interesting files such as build.log, which would suggest that is some kind of sibling of the Bill Gates malware, which is interesting. But another thing is that in the main backdoor, this will start this would run again as a daemon and will redirect all its output to the TMP null in order to not make such a lot of noise. And also there's some logic added for a more resilient replication. For example, in copying itself to the init.d or rec4 rc2.d and so on. Virus total conformist file maliciousness. We see that we got hits from a lot of antiviruses. So it's certainly a Trojan and the backdoor for Linux. So what have we learned? For starters, Drupal security won't work. Why is that? Well, the Drupal security team tried to apply a general patch to this vulnerability. They thought that if we somehow built a sanitization module and we apply it directly at the site load, we will make the attackers go further from the actual vulnerability. So they thought that, well, they might not be able to infer the vulnerability as being present in the rendering module. But we saw that that wasn't true because they actually managed to bypass it. Also, hard release 9 makes bad code, and this is true because after they made a patch for the Drupalgeddon 3, 1 month ago, another vulnerability, let's call it Drupalgeddon 4, has appeared. It seems to be a critical vulnerability. Public exploit hasn't been released yet, but I'm expecting any time from now on. And the last thing, and this is pretty important from my perspective, is that the lack of input sanitization is still a big problem. A lot of vulnerabilities that have appeared this year are based on this. Also, it seems that Drupal, it's pretty bad, again, with another critical vulnerability. I'm expecting that the number of the Drupalgeddon's vulnerabilities that are going to appear from now on is going to be bigger than episodes of Young and Restless episodes. Okay, that's it from me. If you want to read the full articles, you can follow me on Twitter. And thank you for listening to this.
Thank you very much, Emmanuel.
Thank you.
If we have questions, I mean, we sure have questions in the room. Remember, there are goodies that you will receive, so be sure to raise the hand and...
Can I ask myself a question?
Please.
No, I meant for the goodies.
I
so
don't hear a question.
Any questions?
We have a question there in the back. The microphone, please.
Hello, Stefan. Thanks. Oh, it's a little bit down. It's not on, but it's there. I made sure.
We have a hand there.
Hello? No, it's thank you for your question. It's actually the decompiler that is present within the Hopper, this assembly tool. I don't think it's as powerful as IDA, the one that IDA uses, Hexray, but it's good enough for these purposes.
Anyone else? Please don't be shy. We have finished a bit earlier than the schedule, so we have more time for questions if you want to go deeper into the subject. Someone asked, what would be, for example, some recommendations that you would give as countermeasures?
I'm sorry?
What would be some countermeasures that you would recommend for
Recommendations for what exactly? Because I don't understand.
for countermeasures
Oh,
to be
countermeasures, okay.
taken?
Um,
Maybe 3 top ideas. Of course, it's a
Well,
tailored thing to answer, but
I spend most of my time looking through vulnerable code and understand how the vulnerabilities are built based on that. But I don't know, if you're developing C++ code, I say you go directly to the there is this security book of I can't recall the name. Oh, David Secord. It's a great book for understanding how to write secure code. Of course, there are more books for other languages too, but it's a great start to understand the mindset that you have to develop in order to write secure code. And it's a great read too. I recommend it with warmth. That would be my principal recommendation. You just have to. It's an experience that is gained with time. The attackers are getting smarter. They are trying to develop new means to attack. But if you're writing the code based on certain guidelines and it's very audited, then chances are they're not going to get anything from you.
thank you, Emmanuel. Was there someone in the right area raising a hand? No? Okay then, thank you very much.
Thank you.